Hey Honors Chemistry, this is another video having to do with formulas, but this time it has to do with molecular formulas, okay? So, a couple of examples here. I mentioned in the previous video about empirical formulas that we have empirical formulas and we have molecular formulas. So, here's an empirical formula, something like CH, and its molar mass is 13. Here are some molecular formulas of the same empirical formula. C2H2, and its molar mass is 26. It looks like I multiplied that by 2. And since I multiplied that molar mass by 2, I also multiplied the formula by 2. Right? I multiply it by 2 and I get the C2H2. Look at C6H6. I multiplied that molar mass by 6 and I get 78, and I did the same thing to the formula. So to go from empirical formula to molecular formula, I'm multiplying by some whole number. Same thing with CH2O. Its molar mass is 30. If I multiply the formula by 2 and I get a molecular formula, I multiply everything by 2, so 2 times C is C2, 2 times H2 is H4, 2 times 1O is O2. C2H4O2 has a molar mass of 60. If I multiply by 6, I get glucose, C6H12O6. Right, so to go from empirical to molecular, I'm multiplying by some factor. Right, the difference between empirical and molecular is multiplying by a factor. Multiplying by a factor. So molecular is consistent of multiple units of empirical. So look, here's my empirical formula. Here's my empirical formula, but twice. This would be like CH. This would be like C2H2, right? It is multiplying by 2, okay? So the molecular formula of a compound is a simple whole number multiple of the empirical formula. So the difference between CH and C6H6, if I'm going, excuse me, if I'm going from CH to C6H6, I'm multiplying by a factor of 6, okay? Now, each of these have their own molar mass, as I mentioned. Like CH has a molar mass of 13. C2H2 has a molar mass of 26. If I wanted to see the factor, I could take the molar mass of the molecular and divide it by the molar mass of the empirical, and that is empirical, and that's going to be equal to some whole number factor. Okay, that tells me how much larger one is than the other. So if I did the 26 over 13, that equals 2. There's the 2. I multiplied this whole thing by 2. Okay? So if given an empirical formula and a molar mass of the molecular formula, we can determine the molecular formula by dividing the empirical formula molar mass by the molecular formula and getting a multiple. This multiple is what we multiply the empirical formula by to determine the molecular formula. So doing a quick example, calculate the molecular formula of a compound whose molar mass is 60 grams per mole. So this is the molecular molar mass. MM is molar mass. And the empirical formula is CH4N. This is the empirical formula. So I need the molar mass of that empirical formula. So CH4, I know how to get molar mass. I look on a periodic table. Carbon is about 12 grams plus 4 times 1. I'm rounding here. Plus 1 times 14 grams, right? I'm rounding, so I'm getting it about. So 12 plus 4 plus 14, and I get 30 grams per mole is the molar mass of the empirical. Well, here's my molar mass of the empirical. I told you this was the empirical. Here's the molar mass of the molecular. If I want to figure out how much I'm multiplying by, and you could already get the idea, 60 grams per mole over 30 grams per mole, which is this equation I use up here, the molar mass of the molecular over the molar mass of the empirical, is 2. So I'm going to have to multiply my empirical formula by 2. So if I do that, I'll get, if I have 1 carbon here, I'll have C2, multiply H4 times 2, H8, N times 2, N2. This will be my molecular formula. And if you wanted to check, if you got the molar mass of C2H8N2, that would have to be 60 grams per mole, and it is. It's twice as massive. Okay? So this is another video that connects to empirical formulas. This is how I could go from empirical formula to molecular formula. In my next video, I'm going to do a bunch of practice where I have percent composition, and I get an empirical, and then I have to determine the molecular.